Welcome back to our podcast where we explore life forms living in conditions that would not be ideal for most of us. Today we dive into the world of extremophiles with a special guest joining us. For today we have none other joining us than Deinococcus radiodurans, also known as Conan the bacterium. Thank you for coming on the cast, Conan. Thank you for having me. So, Conan, rumor has it your resilience is off the charts. Beginning with the basics, I'm sure we all want to know what makes you so extreme? Well, where can I start? Humans, for example, can't even endure even a few grades of ionizing radiation, whereas I can endure high amounts, up to 5,000 grays. Desiccation, freezing, and vacuum conditions are all things I can survive through. I'm basically a survival expert on these things. That is truly extreme. We all know that you can endure these intense environments, but where are you usually found? Well, I am generally found in habitats that are rich in organic materials, such as soil, sewage, meat, and even feces. But when things get extreme, whether a nuclear fallout or even a drought, my mechanisms of survival take over, and I'm able to wait out and endure these conditions. Very fascinating. Let's dig a little deeper into those mechanisms of yours. What's the secret to your survival? Well, I would say the foundation of my resilience in extreme conditions is my DNA repair system. Generally speaking, DNA strands are shattered by things like radiation and desiccation, but not for me. I've evolved a process to repair these damages. My cells have multiple copies of my genome. I have the ability to put together and replace these fragments. I am also able to produce antioxidants, which protect my proteins from damage, which enables my DNA to be repaired. My cellular machinery is kept running smoothly even under intensity thanks to these antioxidants. Incredible. Now, how about we talk about a bigger aspect of all of this? What do you think your resilience says about the potential for life beyond Earth? My ability to survive radiation up to 500 times higher than humans and environments whether cold, dry, or acidic is a factor that is a gateway for scientists. This leads them to think that life like me could exist on Mars, Europa, or other worlds of extreme. For example, Mars does not have a powerful, thick atmosphere like Earth, and it's because of this that Mars gets a fair amount more radiation than our own planet. Those high levels of radiation, along with a dry surface, can make survival of life difficult. But scientists think that organisms with adaptations similar to my own could possibly have the ability to survive in environments such as these. In fact, even over here on Earth, I have been tested in environments simulated to resemble the extreme Martian conditions to test my capabilities. Resilience like mine shows that life can endure a lot more than what humans have previously thought was possible. That is truly inspiring. But before we wrap up the show, what would you say is one takeaway for the audience about you? I would say my story reminds us of the incredible adaptability of life, and with studying organisms like me, scientists are able to gain insight and know more not only about Earth and its history, but also how the rise of life might occur, and how it might endure on other planets, or past life that may have existed with our increasing knowledge of the abilities of extremophiles like myself. Thank you so much, Conan. Looks like we learned a lot about how extremophiles like yourself are able to survive such intense conditions like desiccation, freezing, vacuum conditions, droughts, and even nuclear fallouts. Thriving through these conditions with survival mechanisms like DNA repair and antioxidant production truly does give us insight of how life could exist in space and other extreme conditions as well. Your story gives us hope and curiosity about what could possibly be out there in the vast galaxies. Well, that's it for this episode of the podcast. Thank you again, Conan, and thanks to everyone for listening.